Did someone say? Did
Weird
someone say?
Trick Mafia.
It's the Weird Trick Mafia. We're back again. Who's here today?
You got Jesse, obviously. You got Andrew, and then you've got Lachlan Evenson. Hello, everybody. It's great to be
Lachlan
here.
Evenson. Welcome.
Thanks for having me. I've
I
been a
heard
big
you have
fan
some
of the
stories
podcast.
to tell. To share.
Yeah, so the stories to share, a little bit about me. So I come from a family of storytellers, so I'm well astute to telling a good story. And my father would always say, you know, never let the truth get in the way of a good story. So we'll see how we go. I was born and grew up in Australia, as my accent kind of alludes to. But I didn't grow up in the places that everybody knows and loves.
Have you ever noticed Americans don't really know accents very well?
Yes, I often get England or some part of England. But yes, not Australian. So I have to kind of explain it to people. So if I'm mistaken for a New Zealander, that's the utmost compliment because they're much nicer than Australians.
Much nicer.
There are like subtle differences between New Zealand and Australian accents.
Yeah, so I'm not, I'll explain how it sits in my ears because I like to say when people say to me, hey, you have an accent, I say, actually, you have an accent. Because that actually makes them think about what the heck is an accent. But anyway, so New Zealanders to an Australian's ear, they do what I call vowel displacement. So if you're saying fish, they would say fush. So they replace the I with a U. If they were saying six, they would say sucks. If it was chips, it would be chops. That would be my ear hearing them. So a lot of it's in the vowel. The vowel is just a little bit displaced.
It also feels more sing-songy to me.
Yeah.
I mean, compared to, you know, South African or like some of the more like guttural accents. Anyway.
Yeah, it's quite a pretty language. I would recommend Flight of the Conchords, which is a HBO
I
show.
love it. Oh, yes.
Awesome. Those people are awesome, but go watch them. I would recommend specifically the one where they dated an Australian woman. It's hilarious.
Oh, wow.
Yeah, those are classic. So you built the internet, I heard.
Yeah, I built the internet with help from a few friends, obviously. So yeah, going back to kind of growing up in Australia, I really loved.
Was Al Gore there?
Was what Al Gore there?
No, just kidding.
In spirit, definitely, almost certainly. You know, I think he's Canadian of Canadian descent, so we have the Commonwealth, connection there. But growing up, I remember being introduced to the internet. It would have been like '98. There was a big initiative in Australia to get the internet to everyone. So outside of the United States, where it was still, it was fairly prevalent, we had access. I grew up in kind of on the border of the desert in a place called Queensland, which is the state. The town's called Charleville. So if you look it up, it's about west. You know where Brisbane is? Brisbane's on the east, the northeast side of Australia, on the Pacific, the side closest to America, as I like to say, because East Coast, West Coast is confusing from different countries. So most of the people live on the east coast of Australia. You go straight inland, 700 kilometers, like 350 miles. It's about 8 hours drive. And this town existed because it was on like a train route. But in World War II, this is a kind of a semi-interesting story. So if you go look it up, General MacArthur, who led the Pacific effort for the United States military, was housed in Australia, and there was a line called the Brisbane Line. So go look up the Brisbane Line, but the Brisbane Line is if Australia was invaded, that's the part of the country they were willing to give away. So the Americans actually housed a lot of their forces and all the Allied forces behind this line. Charleville was right behind that line in the desert, so nobody would think to bomb it. So
it's like a circuit breaker. It's like a circuit breaker.
It's a circuit breaker, yeah, totally.
You can be
so
down.
We have this massive airfield that you can land 747s on. So, this town's small, 2,500 people. In high school every year was about 20 kids in my grade. So pretty small, but we had the internet. And Qantas, as most people don't know, is an acronym. You know the airline Qantas?
Yeah.
It's Queensland and Northern Territory Aviation Service.
Whoa.
So it's an acronym, but it actually flew from Longreach to Charleville. And the only reason it could do that with such a massive plane is because of the World War II airfield they had there. So that's kind of our claim to fame. Anyway, back to the internet. So I started tinkering with the internet, and
so you're born in the Outback, basically.
Born in the Outback, yeah. I was one of those people. Beyond the black stump, it would be the saying that we would say. So that's in the middle of nowhere. Or whoop whoop would be another slang.
I feel like that's more common than, like, I hear of people from Australia, and it seems like almost everyone is like that, or no?
Yeah, I feel like they all have those roots, but most people just cling to the cities or tie themselves to the cities. You know, I'm from Sydney, but maybe they're actually from way away from Sydney, like 10 hours drive, you're still in the same state.
Whoa.
Yeah,
So those kind of perspectives, I mean, you know, for somebody from Arizona, maybe but if you're in the Northeast, 10 hours, you've gone through 5-6 states. So yeah, that kind of capacity. So growing up there.
So you have this love of computers that sort of sparks in the.
Yeah, sparks. So it kind of sparks around the internet. I'm really fascinated. I'm fascinated about how I can be sitting in the middle of nowhere and connecting with somebody on the other side of the world. Like that, like fuses something in my mind. And I grew up with computers in the house, and I was really interested in programming. But it kind of took me to a different place where I was interested in plumbing. Like, how does that, you know, a lot of people say, what is that blue cable that hangs out of the wall? And you don't really care about how the packets get across. Like, if the internet's working, you don't care how it works. But I was one of those people like, you know, how does this system work? So as I kind of grew up, I went to college and I did computer science, but I majored in data communications, right? And it's like, you get down to signal processing. What is Manchester encoding? Like, how much voltage signifies a 1 or a 0? And like how they were doing that in the early days, you know, military times, and making that more available to civilians. But I was really like, I was like the Lego guy growing up. I love putting things together, and software didn't give me that same kick. You know, I never felt like I had something in my hand at the end of the day that I could show people. It was always like, look at this thing I wrote, and people are like, but that's just a black screen. It's like, but I can calculate pi to, you know, the upteenth decimal place. And it's like, yeah, but why do you look in that black screen? And I was like, oh, this is not giving me the kicks I want. So I went into like data communications after college, and I worked on a lot of, you know, government contracts, building pieces of the internet and plumbing things. So yeah, that's
how did you get out of the Outback? And then what's kind of the story? Like, what's the technology and kind of the story that got you to wherever you are now?
Right. So, you know,
like, let's tell people where you are real quick.
What was that?
Where are you right now? Like, where
are I? Yeah. So the destination, I'll tell you the end of the story, then we'll go back how we got here. So I work for Microsoft. I'm a project manager, a program manager, and I work on specifically upstream projects in the cloud native space. So our job is basically supporting sustainable contribution to open source endeavors. So whether that's us creating open source or us contributing to other projects in this space. And that's kind of how I had met Jessie. We'd worked on a few things during her tenure here. So Jessie and I have remained in contact. So that's what I do today.
I heard cloud native is going to be a big deal. It's going to be big.
Maybe, hopefully. I'm betting my salary on it.
There we go.
So yeah, I've heard a little about that. So that's kind of the destination, but yeah, growing up, going to college, doing the comp sci.
So, and where was college? So you left.
Yeah.
College
Okay.
was in the Outback, right? You went to a city.
Yeah, I moved to the city. You know, that was the first time I had McDonald's.
Wow.
Because it was that far away. I moved to Brisbane, which was the nearest city, a college called the Queensland University of Technology. That's where I went. So yeah, that's where I went to college. I kind of got my feet wet. College, like I didn't love it so much as I loved building stuff. So it wasn't like the most useful part of my time, just the way I learn. So when I got out into the field, you know, I was thrown into wireless communications. So this was when 802.11b was out, and building wireless systems. But one of the really cool projects I got to work on was, have you ever heard of free space optics? So using lasers to do data communications. So, you know, 802.11b was like, hey, I can do 54 meg half duplex. People are like, you know, that's great maybe for 2001, but how do you get 10 gig over vast distances? And it turns out, you know, light's actually a really good transmission media to do it through air. So we'd work on free space optical lasers, and the way they'd work is you'd have two buildings or two high points, and you basically tune these lasers, which were really precise in their field of view, and then you would just drive, you know, 1 to 10 gig connections across these lasers. And they have actually done
Seems like
hookups.
fog would be a problem.
Fog is actually the worst thing. So light refraction through fog is
Wow.
was horrible. So yeah, you learn about things like that. You learn about the curvature of the Earth. So how far you can go in a straight line before you hit the, where you can't see in a straight line anymore. I think that's
Someone should like tell the flat earthers about.
Well, they actually told them that, and they actually yeah, go watch the Netflix. They like try to do this experiment, and everything they do basically proves the Earth has curvature, and they're just like finding ways to like explain to themselves why. Yeah. Anyway, they do a laser experiment on that.
I'm gonna watch it.
Yeah, no, it's really good. Frustratingly good, I would say.
So I can only imagine the kinds of people that need this kind of data with lasers, or would be willing to like fund it.
Right. Government organizations and or satellites. So one of the projects that the company I was working with was doing uplinks to satellites for very short periods of time, but you could get very low latency to low Earth orbit objects for 3 to 5 minutes. Just if a bird flew through that laser, it would be instantly microwaved.
Oh my God.
From the inside out. So it's very powerful stuff. But that was really interesting. And then from there, I kind of moved on to I worked on wave division multiplexers. And these are really cool devices if you've never heard of them. But basically, they take light that goes into a fiber optic cable and split it out into different wavelengths. So as we know, visible light's many wavelengths, and then you've got non-visible spectrums as well. But basically, the way that these things work is if you have one piece of fiber, you can split it down into wavelengths and then hook up, GBICs or whatever to either end and split out those wavelengths so that you can multiplex things together.
I read about this before. I never played with it, but basically, like theoretically, each spectrum or each band of the spectrum can be its own channel, right?
Absolutely. And when I started, it was like for one fiber, you might be able to get 12 channels, because the lasers got more precise and more accurate over time and stronger. And then, by the time I was not working in that anymore, you could be 64 10 gig channels, right? So There was coarse wave division multiplexing and dense. And dense was like the ability to split. And the other thing with fiber,
so it's probably both the lasers and the sensors.
Lasers, sensors, and the fiber. Because the refractive index from the glass, what they call it a watermark. So the core of the glass, this is like super interesting to me, maybe other people, but the core of the glass, to keep the light in the core of the glass, like it's bouncing around. It's not in a straight line, and the cables don't sit in a straight line. So you can't go past the refractive index where it'll bounce out of the cable, bounce out of the glass. What that used to be is of the whole core of fiber, it used to be a very small percent in the middle. And they called the rest above the threshold or above the watermark, where the refractive index was too great for you to drive a laser through it. So, but they got better glass.
And then doesn't the refractive index change based on the wavelength? So it would be different for different.
It's totally like go back to high school physics with lenses. It's really, but what they did with the fiber was make it zero watermark. So it doesn't matter where you shoot it in the core of the fiber, you will have equal refractive index for a given wavelength, so that you can basically shove more light down the fiber or the core. So this is like super interesting. And then, I learned about how these cable systems, I was talking about the internet and how we cabled the internet, but basically for a lot of people that don't know, we've actually run cables around the whole Earth under the ocean. And they come to landing points, and basically there's some really good YouTube videos on how they do it, but basically they sink these cables. And these cables have many cores, so many fibers, and they come to these landing points in different parts of the world. And then basically you hook up wave division multiplexers. And, the total capacity of that cable system might be 1 terabit per second, because it's basically what can I divide the light into by the number of cores there are. And every few years, you notice that the capacity goes from 1 terabit per second to 10 to 100 to 1,000. And a lot of people are like, did they lay more fibers? And it's like, no, the equipment gets better, and they just roll in a new kit and plug it in and basically get more channels on that. So it's like super, super interesting. But there used to be a site called Greg's Cable Map where you could go and look at every cable system on Earth. And you can buy waves was what they call it. So if I'm AT&T, if I'm some telecom company, I would lease a wave or a core on these cable systems from, let's say, the west coast of the United States across to Japan, and I would lease that. And companies now, when I was doing that, well, that was all companies would do it and lease it back. But you know, Google and Microsoft and large companies now have their own fiber systems that are terrestrial and, you know, submarine. So that's where I got into that kind of field.
It takes a few dollars, a few pennies to lay that stuff.
Yeah,
for
and
sure.
it's super interesting. Like,
but they group it, right?
They
so
group
like,
it, yeah.
Microsoft and Google could potentially be in the same grouping of fibers, right?
Right.
Or like, I don't know. Do you think like maybe, because one of the problems with Australia is like the latency over, do you think that maybe there will be like innovations in the future or something?
Well, it's so far from everywhere.
Yeah.
That's part of it.
But like, I feel like nothing is impossible, right? So like,
Quantum networking.
Yeah, quantum entanglement on Earth.
Entanglement. Yeah, people are kind of working on this actually. They're trying to.
Yeah, well, it's like it's interesting that you should ask, because a lot of the endeavors are, can I get, because, you know, people look at the projection of the Earth and think that the fastest way between point A and point B is in this direction, when you forget about it being a sphere. And it's like when I fly from New York City to England, it's not like I fly straight across the Atlantic. I go over Greenland and come back down. So with like global warming as one thing, people can run cables up through the Arctic now and make shorter routes. Now, I think the biggest driver for this, like latency-wise, obviously countries, but financial markets. The other thing is like terrestrial cables. So one of the systems that I was looking at when I was working was one that went across Russia, because to get from Tokyo to England for the stock exchanges, the cable systems were really indirect. So it was like, how can we run a terrestrial one across Russia to actually get to England, you know, faster?
Well,
so yeah, that's what I started working on in Australia, and I really was fascinated with language, spoken language as well. So I said, you know what, I've done this engineering job for a while. I'm going to move to Japan, and I'm going to learn Japanese.
So did you get fluent in Japanese?
I did.
Nice.
is it really hard? I feel like that'd be super hard.
It is hard. Japanese is kind of a tricky language because it doesn't have like the sound or whatever. So however you say something is the right pronunciation. So you don't have to worry about that. But it gets harder because the written script is basically retrofitted. So yeah, like in computing, this is a really good analogy. It's like you took the spec and modified it to a different runtime. So basically they had no written language in Japan. They had spoken language. The monks, the Buddhist monks, went over to China to do, you know, a tour of duty in China. They came back and they retrofitted the Chinese language to the Japanese sounds.
Oh, that's very confusing.
So I'm far from fluent in Japanese, but I like studying languages, and it's like the kanji are this retrofitted Chinese characters, and then you have two different alphabets, because you have one alphabet for the native words, and you have another alphabet to designate the words that came from another language. And so there's like, yeah, it's crazy.
Wow. They're called the kanji.
Kanji is the Chinese ones, and then there's like
hiragana. I feel like that's also a breakfast food with like egg and rice and like milk.
Yeah.
That
right. So one of the sayings like kanji. So for the Chinese characters, to read a newspaper, you'd have to know a minimum of 2,000 individuals. But the really interesting thing that we don't have with Roman letters is they pack meaning, like the ideograms. So it's like to draw a tree, you literally draw a tree. To draw a forest, you draw 3 trees together. To draw the sun, it's the same as the word for day. So it's like a day is one sun. Okay, that makes sense. So there's a lot of like intrinsic meaning that we don't get from the alphabet. That's super cool. And they're like Legos where you can click them together and have denser meaning.
There's like a long philosophical conversation about how language shapes your thinking, right? And each of these languages kind of imposes a paradigm on how you think about the world, whether you like that or not. It's true. And I feel like, I mean, I'm not fluent in Japanese. I study a bunch of different languages, and I'm kind of mediocre in a bunch of them. But basically, like when you think about things in Chinese or Japanese, like it's actually slightly different framing in your brain.
Like, I totally got that. And people would say, I lived there for like 3.5 years. People would say to me, like, do you dream in Japanese? And I was like, I don't know what that means. And it caused me to question, like, what is my inner dialogue and what is my inner thought? And more often than not, it's constructed in the way that we speak, the way that I rationalize my thinking, which I think is super interesting, right? So,
That's
but
great.
like the end of it, I actually had a dream one evening, and the whole thing was in Japanese. So the interesting thing before it, it was like when I would speak Japanese, I would literally be passing Japanese back to English before it hit my brain, before it hit disk, right? So it'd be like,
It's like you got out of the VM and you got a new operating system while you're.
oh, it's totally that. And like, it's inefficient, it's slow, it's error prone. And Japanese does these real interesting things. It's not redundant. Like, English is really redundant in, like, you have to say who, what, when, where, and why in almost every sentence. So if you miss bits, you can catch up on the context. It's like, today I rode a bike, then I did this, then I went to work. So you have like the sequencing and who did what. Whereas Japanese, you just do the setup, then just rattle off verbs. So it's like, today I woke up, walk, ran, swam, went to bed.
What?
So if you cut in at the walk, it's like, I don't know who, I don't know when this happened. The other thing is tenses. So we kind of have past, present, and future. Japanese only has past and future. There's just a way that you could designate that the future is happening right now.
That's crazy.
Which is, it's like, those things are like mind blowing.
So how did your dream take you from, I mean, you had this Japanese dream and then when building the internet, how's that end up in cloud native Microsoft?
Cloud native, okay, so this is great. Okay, so it turns out that school I was working for to actually teach English to Japanese people, to fund myself studying Japanese in Japan, went bankrupt. Now, I had to basically get a job, or my visa was null and void in Japan. I was 6 months in. Everybody said I was crazy for going to Japan and not being an engineer. I had a good job. You know that story, right? Don't do this. You've got a great life. But I was like, this is the time to. I actually went back into engineering, and I fell into a job in the kind of the financial services. We wrote exchanges for banks that was headquartered in New York City, but we had a base in Tokyo. So I picked up that thing again, but in the spirit, it wasn't government agencies. It was actually connecting exchanges. So like financial exchanges. So this is like low latency stuff, cable lengths, all this stuff matters. And I got into that kind of world of how to route traffic between markets, but from the infrastructure up.
And so, are you trying to do like the anti-arbitrage type of stuff, or
the software on top? It was owned by an independent sovereign entity, so banks could trade with each other.
Yeah.
And do all those kind of things, because banks usually have their own platforms, but this company had its own that was not owned by any bank. So they would trade with each other through this platform.
So it wasn't trading stocks in like the high frequency type stuff. It was mostly the clearinghouse or that kind of stuff.
Yeah, so we were connected to clearinghouses. We weren't a clearer ourselves, but basically we would give you the market data, which pricing data is also really cool tech if you want to get into like multicast and dropping ticks.
Yeah.
Because what you see on your phone when a stock changes is actually you're dropping like 10,000 changes per second, just so you can see one. But we basically presented ways for people to slice up orders in different, whether they were equities or bonds or all those kind of things. So yeah, we were working on that. So I did that for a couple of years, and I had the opportunity to move to New York City. When I moved to New York City, that was the head office of that company. I still kind of built data centers and built pieces of the internet and connected exchanges. But I found the networking piece kind of boring after a while. It was never changing, and people were happy with what they had, and nothing much had changed. So I liked the automation movement, right? And network devices were really horrible to automate. And it was like, if I have to configure another BGP router, I don't want to do this. So I started getting into virtualization and automation, and that's kind of where, from there in New York City, I got the opportunity to come out to Silicon Valley because I was looking at starting to do networking at higher level abstractions. So the cloud was becoming a thing, and I was like, well, how's networking work there? And then I looked at it, and it was the same thing as how it always used to work, just at a software layer. And then I went, I'm out, let me go do automation of services and distributed systems. So it was funny when I think about the internet that I was working on and what I work on now. It was like, when I first look at Kubernetes, for example, I went, this is MPLS for workloads. And this is such a networking person. It's like, we have a way to switch labels on networking traffic around the internet.
It's almost like the language that frames how your brain thinks, right?
It's exactly how it is. And it's like, I don't want to think of it like that. And it's like BGP is just a state machine, that holds the information of where to put a packet. And, I realized that a lot of the work I'd done that set me up in the internet space, it set me up around understanding distributed systems, failures, tolerance, availability.
So watching this kind of networking thing evolve in the cloud native, from someone who has such a core kind of networking background, doesn't some of it feel kind of inefficient and like sloppy? Or like, how do you think about because it, like, when people start talking about underlay, overlay, like all this stuff, and then we're going to have Istio and then like, does it actually work? Like, it just gets where it's like, oh, it'd be nice if this just worked and like was fast.
Yeah, absolutely. It does feel inefficient. And, I remember measuring, you've all probably done this, but it's like, how much can you keep in an ASIC so it doesn't have to be CPU switched, right? As soon as a packet would leave an ASIC in a networking device, your throughput goes to kerfuffle. And basically, however complex of a decision matrix to route a packet through the kernel you had would be how many times it had to go back up through the CPU. And each one, you would pay a tax. So when you're talking about terabits, gigabits per second, this is the biggest inhibitor to. So, there's always been that, is it just software? Is it a mixture of software and hardware? Is it FPGAs? Is it ASICs? And how do you do that dance of, because, there's people who are just like, I can run everything in the Linux kernel, on any commodity hardware. Cumulus Networks was built on this, right? But once you get up into the higher level abstractions, it's like, how many times do you have to go through a CPU, and can I offload those decisions to some lower level abstraction that knows how to build and push a hash table into an ASIC? Like, that actually matters. So
yeah, that's why I like eBPF and the promise there, because like you can filter a packet before it even like allocates memory.
Right.
And it's like, just do it before anything else happens, because I don't want to have to deal with it. But like, that's nicer than, but just doing it on hardware is even better than that. So.
But what about all these IP table rules that we have?
I feel like you're trying to rile me up again, and it's not going to work. I am resisting.
Yeah, totally. So looking at, I always like to say, my overlay is somebody else's underlay. Or, the inverse is also true. So you are sitting on top of software somehow. It's just how efficient are they at pushing a packet through a decision matrix and getting it back out on the wire? Because none of the text changed. I think the biggest thing that's riled me up a lot is I was on the IPv6 bandwagon very early.
Oh, yeah.
And like, I learned it, I worked in it, I did dual stack, we did 6 in 4. So one of the great ways to actually scale your network was to put all your IPv4 on v6, because then you could abstract it. But the uptake of v6 has been really slow. And I think that's, around tooling. People love decimal, they don't like hex. So
nothing will change until there's a crisis.
Nothing will change, exactly. So, and I think people, as much as they rag on DNS, like DNS then becomes critical for IPv6 to be user-friendly, because you can't remember addresses anymore.
Who remembers an address now?
Anyway, yeah, I feel like I was really good, but for a long time I could know all, I took pride in knowing IPv4 addresses, but I gave up. But you can get vanity prefixes in v6. Facebook owns FACEB00C or something, right? Whatever in hex. Cool. So you get the vanity prefixes, you get the /16, and
that's cool.
Okay, I can see Jesse's wheels spinning now. She's like, I'm gonna go get my
vanity. Got some more money.
Yeah. I'm sure they're dirt cheap. You can get /32s for almost nothing.
Well, so also I was looking at the difference between the RFC for IPv4 and then the various RFCs for IPv6, and it's like they only became more complex. Like, shit is not getting easier. It's getting more intense. And it's like, how much of this do I have to actually implement, and how much of this is like not real? Like, how do you know?
Totally. Yeah, it's and it's, you know, v4, IPv4, which was all fixed headers, no extensions, right? So what happens with things like Envoy is they start stuffing stuff into the payload, right? Because it's like, I don't have any space in the header to signify one thing from another. So I start getting into the payload. V6 has extension headers, and you can slap on as many as you want. So I think not having a space where people have thought about extensions has made people go, well, I don't know what to do here. Whereas IPv4, people
We'll put it in the payload, Lachlan. What are you talking
yeah, we'll
about?
put it in the payload again.
No,
Whoa.
no. This like irks me actually also because I've seen people do horrifying things with the TCP spec. So
Yeah, totally.
So now assume everyone kind of has the internet, and we've kind of taken for granted that we do, and we can share information, you know, even if you're in the outback, or I've had video conferences from the middle of Africa, from, you know, all these places on the planet. There's this other topic that you kind of introduced when we were talking offline about net neutrality, and you had some thoughts, and maybe you want to kind of frame that, and then we'll see where that goes.
Yeah, totally. I think, you know, the stem of the interest in the internet was around connecting people. And, you know, my work, distributed systems, hangs off the internet, right? It's something I take for granted, just like the water in the faucet, right? Every day. But my passion around that was just connecting people, right? If we got information to people who didn't have it before, I think that's a plus for society. And you know, open source probably wouldn't exist the way that it does today without that information. So I brought up net neutrality because this is something that I think is fairly concerning and horrifying for me. But I also would be interested to get your thoughts. But, you know, just to frame net neutrality for people who are listening in and don't know what it is. So everybody has access to the internet in its entirety when you pay one fee to your provider. If you get rid of, so the net is neutral, people don't favor content from one provider than another. What the abolishment of net neutrality would mean is, I'll kind of boil it down to how it would affect me as a consumer is, I don't go to Comcast or my provider and say, I would like an internet connection. It's like, I have to pay for Netflix as another fee. I have to pay for Google as another fee. I have to pay for Wikipedia as another fee. And so basically I will get a view of the internet based on how much I can pay. So that segregates access to knowledge for people. Therefore, people who have more money have more access to knowledge. People with less money have less access to knowledge. And I feel like for the internet and the idea it was built on, that is not in the best interest of humanity, would be my kind of point of view with net neutrality. But I'd be interested, Jesse and Andrew, on your kind of perspective.
Yeah, I mean, it's hard because there are two sides to this, and like I see like companies like Facebook take, you know, these like really cheap hardware chips, and then they kind of like create with telcos like ways of, you know, connecting people in places that would never be able to have the internet. But then the internet they get is like this very Facebook oriented internet. But it's like, cool, you can connect with other humans, but you aren't getting all the information that we have. So that like also makes me sad as far as net neutrality. And I kind of wish like they had the power of the internet that we have. But then also you see these academic sites, you know, almost like ACM. If you want to download a paper, you have to log in and like be an ACM member. And like that's like JSTOR as well. That's also like this.
All of the academic journals are behind paywalls.
Yeah.
Like all the real research.
So it's sad that like people can't access that information as well. And I know like people have done it and, you know, gone to the court battle in the past and like, you know, freed all these things from behind the paywall. But like, is that worth it? You know, going to jail over it? I don't know.
Well, for the listener at home, you can almost always get any paper you want from the professor if you just email.
Oh, that's good.
Right. Okay. Yeah. Good advice there.
That's one little thing. But also, I don't know, trying to be balanced, and I don't know how many different rabbit holes we want to go down, but in some sense, like it calls into question like the ethics of capitalism and like how all these things are, like what's the motivation for building these things in the first place, right? And there's also like this vein around some of the stuff like surveillance state and like the way some of this stuff's being used or misused. And your employer, I think there was a headline I read either yesterday or today, something about like they didn't do a contract because they were worried about the abuse of the spatial recognition technology, right? And like being able to have access to some of this information, when you start to aggregate all the information, like it enables some things that are great, but it also enables some things that are not as great. And it's just a kind of a question of like, who are we building this for? And I think most people on this call, and hopefully most people listening, would want things to be better and better for humanity, whatever that means to each of us, probably slightly different. But it's also like very capital intensive to build this stuff in the first place. And for the most part, that motivation is largely to collect rents or to make money off of it. And so I used to work a long time ago in ancient history. I worked for a company called America Online, and I feel like you sort of see these patterns of like aggregation and disaggregation like happening over and over again. I think in some ways, like Pandora's box has been open, and now that we can kind of talk to each other, we're not going to really stop talking to each other. We're not going to stop connecting, but some of this content and some of these things people are doing, it might be, unless we're like activated politically, then have the political will, like it's probably at some point going to be hidden from us, at least certain aspects of it. But then, as Jess pointed out, a lot of it's already hidden in other ways, right? And if you wanted to disrupt something about how humans have access to information, I feel like disrupting how these academic journals and research is available would be huge. Like that would move things forward. Like I run into this probably at least once a month where it's like, I'd like to read this paper, and then it's like hard. And like, maybe I'll get it later, maybe I'll get it from the professor, whatever. But like having access to information is something I think near and dear to everyone here's heart. But it's not always exactly how we'd like it.
Yeah, totally. And the business models of the corporations that are providing the infrastructure was initially built on the fact that they were delivering that physical infrastructure, right? So they're all making that move to become content companies because, once you commoditize the infrastructure, you can't charge a premium for it anymore. And then their business model's shot. So they've got to kind of adjust. And this is where you see companies, like Netflix has probably forced the hand of a lot of companies to create content. But coming from and doing my time as working on ISPs and things like that, it's like you want to get people's traffic off your network as fast as possible, unless it's destined for you. So if you transit people, if you're a transit organization, you want to peer with Netflix, for lack of a better example, as soon as possible, so you can get their stuff off your network, because that's stuff you can sell to somebody else. So, and this is, I feel like I understand the motivation to get rid of net neutrality from a business perspective, but I feel like the unintended consequences are much greater.
I mean, this is a game we're playing, right? We're constantly in this conflict, especially as technologists, with kind of the ethics of all these things that we're doing. And this is maybe not the perfect metaphor, but I think it's related to what we're talking about, which is this Boeing 737 Max. Basically, like they sort of like in-app purchased safety for these airplanes, right? So if you didn't have enough money or chose not to for whatever reason to pay for safety, then you didn't get safety, because that was like a little software upgrade. And so now we plowed 2 of those planes into the earth because someone somewhere, and obviously engineers were part of this story on some level, and then there's obviously other people involved that made decisions, but someone sitting in whatever, like they sleep, I don't know what language they dream in, they decided what we're going to do is we're going to make money monetizing safety, right? And so like that's maybe a far end of the spectrum, but I feel like the way the game is set up, people are always going to find ways that they can try to capture value, and maybe some of those are going to cross these lines of what we would consider ethical.
Yeah, absolutely. I really would love to see, people have got to get out of this kind of bricks and mortar economies, like digging stuff out of the ground and selling stuff that we dug out of the ground. Like the value for, the people is their minds, and giving that access, like their educations and their understanding. Like the sooner we get out of this, like I'm selling copper and I'm selling access to people or I'm selling not distributed knowledge. I feel like that's a much better, more scalable model. But that's obviously has its own set of challenges.
I mean, I feel like we're right on the edge of both this conversation and us as a culture and technology, where no one really needs to work, especially kind of like mundane tasks, right? So in a world where the economy has been based on labor, if you move into this world where, I mean, there's two pieces to it. So one is that there's probably no reason that anyone needs to do kind of a lot of this manual work that people have depended on for their livelihood for whatever reason. And I'm not going to say basic income, but I just said basic income. And then on the other side of this, when you think about creating these things, the type of work that it is, the mental models that you need to make good software to create the experiences that software enables, if you manage that like you're digging copper, if you manage that like the Taylorism Industrial Revolution, which is essentially dominated management thought process for decades or century, however you want to think about it, like we're evolving out of it, and there's pieces of us. I think DevOps movement has captured some of this, Agile has captured some of this, where it's like knowledge work enables these things, but if you try to treat this process like digging ditches or building widgets, you're going to have a bad time. And I feel like most of the big IT failures that you see are because people managed their IT like they were like they're digging copper.
Yeah, totally. And the systems, like I always think about, the trash system, right? It's like if you want to recycle or compost, it's actually really hard to do because the system is set up for you to waste, right? So intrinsically, you're fighting against the system that's been set up, and you're displacing a lot of people from work, and you're displacing a lot of systems that rely on the fact that there's going to be trash in the ground. But there's a whole pieces of the economy set up for that. So like when you feel, oh, I just need to compost or recycle, why is that so hard? It's because there is a whole thing to make you do that.
And that creates its own inertia, right? Well, once you've created like people who have their livelihoods attached to a task, they're going to do everything they can to preserve that task. And this is, watching people try to adopt network automation is a perfect example. System automation is another example. It's like, oh, don't tell us how to do this thing with networks. We did it for a long time. We know what we're doing. Like, we don't want to change.
Absolutely. Absolutely.
Yeah, so I feel like that's been a whole episode, and thank you for coming on our show.
Yeah, absolutely. Thanks for having me, and congratulations on the podcast. I've been enjoying, and I look forward to every week seeing a little snippet. So I love the dichotomy between both of you and the way that you reason. So thanks.
Well, we're having fun with this happy little accident, and we'll probably keep making these for a while. So
yeah, no, it's
keep it
dope.
up.
It's dope.
I'm creating fans out there. Hopefully, I'm like, you got to listen to this podcast. But thanks for having me.
Here's a little plug. We need people to subscribe to YouTube. Once we get to 100, we're like most of the way there. Then we get
a custom URL.
Yeah, then we get advantage.
Okay, you have my vote. I'll go subscribe after this.
So that's everyone's action item. Subscribe.
Okay, do it. Subscribe.
Right. Perfect. We'll call it Weird Trick Mafia out.